Okay, today we're going to be going over an 820-3115 that is absolutely 100% dead. You plug in the charger, and when you plug in the charger, you get no green light. So I want to talk about what could possibly be wrong with this, and let's just go over a little bit of diagnosis. So what I want to do here is I'm going to check with my multimeter, which you can't see in the damn super zoom out that I have with the camera here. So let's just get that a little bit more in view. So what I'm going to do is I'm going to check a few voltage rails here to see what I get. So when I check I'm going to check PP3V42 because I have no green light on my charger. So when I check PP3V42, the reason I'm checking that is because that's what the one-wire circuit works off of. If the one-wire circuit doesn't work, I won't have a green light in my charger. If you don't know what the one-wire circuit is, search the channel and find the one-wire circuit videos. They'll be very helpful to you. I can't re-explain that entire circuit every time I do a video. Now, I get 3.4 volts, which means that, I have the one-wire circuit, the voltage is there for it to turn on. So if I have no green light, you could look into what's wrong with the one-wire circuit. I'm going to take a little bit of a shortcut. Now, one of the things I notice every time I have a board that has a dead SMC, every time I have a problem with the SMC and the SMC is dead, my PP-G3 hot voltage is down by about 2 or 3% from what it's supposed to be. Now, over here, my PP-G3 hot voltage is 12.24 instead of the usual 12.53 or 12.6. And that gives me an idea that my SMC most likely is dead. Now, if I were to move over to the microscope camera, which would require plugging it in, I would get a little bit of a hint as to why it is that my SMC is the problem with this board. So let's go over what I've talked about in other videos where oftentimes, everybody's asking, how do you measure this chip? How do you measure this component? How do you know this, that, or the other? And it's everybody wants a definite answer, and you don't have a definite answer. The way I measure it is through brains and eyes. So again, every time I've had an SMC where I know it was dead because after replacing the SMC I fixed it, I noticed that my PP-G3 hot voltage went from 12.22 to 12.6. So now in the database, in the brain, I have stored that my PP-G3 hot voltage will be down because remember the SMC communicates with the ISL 6259, which creates PP-G3 hot. I have in my head that the SMC, when dead, will, for some reason, cause the ISL to be down by about 3%. Now, if I were to look really closely on the microscope, here we are. I would look by the SMC, and what I see over here is that there's corrosion in this section of the motherboard. So when I look over here, right by the SMC, you have red probe points, and also this, which is no good. Now, one of the things that I'm going to do really quickly before I make a complete idiot of myself is ensure that the SMC reset signal is present. So let's go over to the schematic and show you what I mean by SMC reset. So a lot of chips have enables, a lot of chips have signals that tell them when they need to turn on, and the SMC is no different. Come on, Open Broadcaster, play along. So we're going to go down, and right over here you can see in the power system architecture. So we have the power coming in from the charger or from the battery, and it's going to flow, and it's going to come here where it makes a rail called PP3V42. That's going to go to a chip that creates SMC reset, SMC power good. It creates SMC reset, and that then goes into the SMC. And the whole idea behind this signal is that it makes sure that this rail is working and good and is stabilized before you turn on the SMC. Now, let's see if SMC reset L is present, because if SMC reset L is not present, I won't have an SMC turning on, and if my SMC doesn't turn on, well, there's no point to replacing it. Wouldn't that be dumb to replace a chip that's absolutely miserable to work with and just because it wasn't being told to turn on? That would be pretty stupid. So let's look over here and see if my SMC is being told to turn on. So I'm going to scroll over here, find which pin it is. I should really have this memorized by now, but for some reason there are just small things that I forget to memorize. So we go over here, I'm going to plug my DC board in, and let's measure for SMC reset. Now, obviously, I'm hoping that my SMC reset L is not present, because if SMC reset is not present, that means there's a problem with an 8-legged IC instead of some 90 or 96 ball chip. But I know that I am not lucky like that. I know that my life does not follow that convention where my fixes are always the easy ones. And wait. Whoa. Seriously? Did I just say that? Did I just say that my life does not follow a convention where my fixes are the easy ones when Motherfucker. I fucking fixed it, man. Well, look at that. Oh, SMC. You fucking idiot. You fucking moron of a repair shop owner. It was a bad DCN board all along. A bad fucking DCN board. A bad DC fucking in board. I deserve to have this little fly in my office. I deserve to let him land on me and buzz by my ear. And, you know, taunt me and tease me and fuck with me because today I'm an idiot. And I'm going to post this because it's important for the rest of the world to realize that I'm an idiot and that I do stupid things and that I make mistakes and that I jump to conclusions when those conclusions are just completely baseless on bullshit. Sometimes you get tired and you're just not focused and you do dumb things. And I was so close to literally just doing motherboard repair on something that does not need, well, it does need a little bit of motherboard repair. It does need a little bit of motherboard repair, but not the level of motherboard repair, like super motherboard repair that I kind of would have thought. So let's just finish this and do the sensor and never mention this again. So might as well replace that shit. Oh, yikes, that is gross. Oh, and the via to the other side, too. Oh, okay. And you okay. Alright, so this is going to suck a little bit. Oh, no, I kind of like figuring out circuit problems. I don't really like, just robotically running wires from one side to the other and checking shit in Landrex. That's just kind of gotten old. You know what I'm saying? I hate using Landrex so much. I hate Landrex with a passion. So this is going to be a much more boring board repair than I thought. Let me knock off the same old sensor chip from the same old spot. Boring. You know what? That may actually be good. And I probably have none left since I'm so used to stealing that shit that there's really no point to replacing what may actually be good. Just a case of a little bit of an oxidated solder joint. Let's get that stuff sucked up in here. So all that junk, I just get, yeah. All the junk inside of in that connector is just going to get sucked up into that little solder and flux ball that I created when I did this. The idea is not to have too much flux on my solder joint or too much solder on the joint. The idea is to just have that little bath remove all the junk, which it did. And then we will see if it passes my sensor test. This one, on the other hand, what are the chances that I can heat that? What are the chances that won't need a wire to the other side of the board or some stupid shit like that? Can we scratch away at that? Can I fill that via with solder? Is it gonna happen? It doesn't look like it's gonna happen. Yeah, that's not happening at all. Oh well, wires will have to be run. Let's grab 3115 board. And this shit is really getting monotonous by now. I mean, There is something about fixing the same, like, this used to be the coolest thing in the world. The idea that I have figured out what maybe less than 0.5% of the people that repair these products know, and that it was all done in a fairly short time period. That was cool. But just like sitting here and going through it again and again and again and again and again and again, it's just bleh. Boring. Super boring. I'm excited to find the next thing for myself. I don't trust those Boardviews for shit. That is not even remotely placed. Let's set my JBC. I'm not used to this JBC. I'm used to knobs and knowing where I am on the knobs. I've never really had a clue where I am in like Celsius or liters a minute or anything like that. Okay. So I'm going to have 2 wires to run here. I like this tip. This tip for the HAKKO FM 2032, this is the T30-KN. That's T30-KN. The reason I like it is because if I need to like flow a large joint, I can use the blade. Or if I want to do a QFN, I can get a bunch of pads at once with the blade. But if I want to do one small point, I can turn it into a micro tip by just turning it around. I like tips that have multiple tips in one. I like tips that where you could like turn it, and that's what I always liked about the curvy tip. I could use the elbow of it to flow a larger joint. I can use the edge of it to flow a smaller one. This is usable for a lot of different applications. It's just very, very flexible. Good stuff. See. All right, so now I have to go back on the screen here and figure out where those 2 things go. So we're going to go back to the Boardview software, which when I put it to full screen will not work because it was made in 1995, because I'm not allowed to buy working fucking Boardview software because I work in an industry where you're not supposed to be successful. So you're supposed to fail. You're supposed to wear a little fucking Apple Genius Bar shirt and make your bullshit-ass salary to smile at people while you sell them overpriced crap that's designed to fail one day outside of your AppleCare warranty and then get a middle finger. And if you don't want to do that, you're a fucking criminal. How dare you have schematics to work on our stuff? How dare you have anything other than a 21-year-old fucking Boardview program? Yeah. Yep. I'm a regular. Huh. Okay. And you read about this shit. You read about stuff like stores getting raided because the backs of the iPhone 4s had Apple logos on them, and sites being shut down because there were schematics being distributed. It's like, you'd think that we're fucking Jihadi John or something just because we decided to fix consumer electronics, like we're fucking killing people or something. It's not really the case at all. It's bullshit. Oh, so this is where it gets even better. See this? So when you hit N, it's supposed to show you where a certain signal shows up on the board. So see over here where I type in iSense _HS _other_N. That's exactly what this says over here, right? Watch when I hit OK. Not found. You fucking piece of shit software. See, I feel like I've been there before because I knew that this was going to be stupidly miserable, but I just didn't really understand why. Okay, so let's look in the fucking schematic and try to see where that goes. Now I'm going to load up the schematic, but since I resized the Boardview software, that's going to stop working. So let's go over to U5410. Okay, so the pins that I'm looking for are pins 4 and 5. So that attaches to these pins of R5410. R5410. So before I go there, I want to see which one's the N and which one's the P. So the P is on the bottom and the N is on the top. So let's just think of it like negativity is on top. That's the theme of this video. So that's how I'm going to remember that the N is on the top. Might as well rotate the board view so it's same way here that it is on the desk. Alrighty. Where's my board? Here we are. Alright, so the N is going to be the N is on the top. So now we look for R5410. Where the fuck are you? Of course, you're on the other side of the fucking motherboard. Of course, you're right on top of the heatsink, which I have to remove again. Fuck you. And of course, this is set up where I don't know which pin is what, because this does not match the shape of it on the fucking diagram. This does not match the shape of it on the motherboard one bit. Alright, so let's see. Fuck ass old bullshit software. Alright, so let's take the heatsink off and let me show you why this is bullshit. Let's see, this is the view that I'm looking for. Alright, so I take the heatsink off. So you see how the resistor looks over here? This is what they say I'm supposed to find in that section of the board. This is what's actually present. This looks nothing like this. This and this are two fundamentally different fucking shapes. This is dumb. This is bullshit. And of course, you can't complain to anybody because, you know, again, you're not supposed to have it to begin with. All right, so let's see. So this, and again, the board view is a different shape here than it is on the table. So let's just turn this around so it matches. So let's see. So the right side is going to, I'm going to guess the right side is if I can ever click the fucking dot that's on the second to the right. Here we go. Can I click this one? Will you let me click this? How much do I have to zoom in before I can click this? Can I click it now? I want to click this one. See? I'm clicking. I'm clicking. Oh my god, it's impossible. Suck my... oh my god. Okay, so the left side is going to be the N, and I'm just going to guess that this one over here that I can't fucking click is the P. Hopefully it passes the sensor test from my assumption because I can't tell from looking at it. So we're going to solder that. Okay, so let's get started. So we are... oh, a nice little wire. So this side here. Just tin this with some leaded solder, even though there was originally lead-free solder there, which means we're doing something that's super not IPC certified, super not Apple certified, you know. And let's get my wire. Then I'm going to solder to the other side first, and then I'm going to... because keep in mind, remember how I said cutting this wire to exact length is a pain in the ass? Here's the problem. Cutting this wire to exact length is a royal pain in the ass. So I can cut one side, and it's still kind of difficult to tin this shit without actually cutting it every time. So what I like to do is I actually like to scrub off the insulation into the joint. Now, what's easier to scrape, a wire by a really small leg or a wire that's by a huge resistor? It's going to be the wire by a huge resistor. So I do this. I scrape my wire a little bit. I tin my wire a little bit. And what I wind up with is something like this. Now what I'm going to do to make that a nicer wire, a more usable wire, is I'm going then to cut off half of the tin section. And after I cut off half of the tin section, then it's going to look like this, which I can actually use. Let's see. So now we solder this wire over here. Remember, the top one of the two is going to be the N. Glitter is made. I'll have this one shaped like this. That's some pretty awful work there. That leg is bent. And then when I do this, the wire is going to pop away, you'll see. Okay, we have to push that down so that it's not awful work. Remember, flat on the board. But doing that will make a bridge. Luckily, I have this tip that will allow me to remove bridges. So I put a little bit of flux over here. And we'll remove my bridge. Hopefully. You may ask why I don't use a thinner tip. The other tip that I have for this is the total piece of shit. It only gets hot literally at the exact tip of the iron, but nowhere else. So it's virtually impossible to solder because you have no actual area to solder with. So N was on the top, and now on this one, N is on the left. So this is going to come around like here. To this side. And we're going to scrape it in there. So you're going to see what I do. I'm going to scrape it in. So this is what I'm going to... This is how you make a wire that's exactly the length, by the way. If you think that I'm cutting and measuring this shit, you're out of your damn mind. What I do is something like this. Now remember, I want this to be nice and flowed in. Come on. So I scrape and I scrape and I scrape, and the insulation has come right off. Now I'm going to hold it down. The tweezer. It's flat on the board. Let's make it flat on the board. Let's make another IPC certified jumper. An Apple certified fucking jumper wire. Look at that. Look at that. Look at that. Oh, if the folks that turned me down from my cashier job at an Apple store 10 years ago would see me now. Oh boy. Thank God. Can you imagine what it would be like working at the fucking Staten Island Mall? Selling Apple products to Staten Islanders. That sounds like it would have been a really awful life. That would have been awful. I dodged a bullet there. There are so many places. I remember just being so sad that I didn't get a job that I applied for. And I just look back on life and I just think about, like, what would have happened if I had actually gotten the job that I had applied for? You know, how much shittier would my fucking life have been had I actually gotten the jobs that I wanted? It would have been really bad. I mean, just, ugh. I don't even want to think about it. All right, so we're going to take this wire right over here. And let's see if I can do a little bit of tinning without scraping it on the table. Usually I actually have been taking the tinning this on the USB port cover of a dead motherboard. That does it too. So we grab it by the end. There we go. It just kind of tinned itself a little bit there. Unfortunately, that's a little too long for my tastes. I don't want to have that much not insulated. So I grab my wire and I'm going to cut the end of it a little bit. Add some fresh solder to the pin that I'm working with. Thank you for beeping, HAKKO. Place my jumper wire. Ah, yes, nice and IPC certified. Are you IPC certified? Because you have a business, man. You need IPC certification, man. How are people going to know that you know what you're doing? How are you going to be a professional? That's exactly what I want. I want to spend my money on a fucking certification that qualifies me to make $11 an hour in a job where it's expected. It's not just like, it's not just implied that you're an idiot, but they actually make keys for this purpose. Like, you see this thing over here? This is a key inside my soldering station. The entire point of this key is because they expect that the IPC certified operator of the station is so fucking stupid that they don't have the qualification to set their own temperature. So it's a lot of companies do this, where you actually can code the station with these little cards, where if the card is not present, they are not allowed to adjust the temperature. And the entire reason this exists is because they assume that the person that's operating the rework equipment is so dumb that they are going to break everything if they so much as touch this, that they have to be restricted from accessing temperature. And you want me to get a certification to be in a business where you're paid like 11 or 14 bucks an hour and expected to be so fucking dumb that you're not qualified to set the temperature of your own rework station? I mean, just... Yeah, I think I'll pass on that and go with owning my own business, but whatever works for you, man. Whatever works for you. Okay. The unsteady hand just fucks with everything. But I'm good enough to get around it. All I want to see, this can't touch that, because that little edge is exposed over there, and that is for the trace above it. You can't see that because it's dark as hell. So, this is going here. This is going to a different part of that resistor. So this part, see where it starts to get exposed, cannot touch that. That's really what I'm concerned with. But at the same time, I want to know that this, that's soldered in there nicely and that I can drag the board around by it. And I don't quite feel that confident in it just yet. I want to see that that's really pushed in there. And I would get that confidence from the wire coming in straight on, but I wouldn't have a lot of room to bend it if the wire came in straight on. So here's what I'm going to do. I'm going to do something that's a little unconventional. I'm going to actually solder it in there all the way, and obviously that's going to be touching that. And then I'm going to pull it out, or try to pull it out, see if that succeeds. That was a terrible idea. So how about this? How about I put this one on first, and then I twist it off? This is supposed to be a really easy thing to do, and I'm kind of making it complicated. You really shouldn't be doing that. So I'm going to do this. Watch. Kind of what I should have done the entire time. Okay, so that wire is in there exactly where I want it. That's what I want. So now I can twist off this shit, this excess garbage, right over here. Definitely should have started with that one first from the beginning. So that's a joint that I can live with. Now I have to redo the one that I should have done second instead of doing first. So that's what I would have done if I had half a brain. So let's go over to this one over here. And put that back where it belongs. Did I seriously just do that? Oh, man. Well, at least it's tinned now. Ah, nothing is working today. Down a basic jumpers, nothing wants to work today. Come on. Come on, hand. There we go. Listen to brain. Good hand. Alrighty. I will live with that, because if I try to make it any better, I will just wind up screwing it up looking at how everything has gone today. So that is going to go there. And this can now go to the other side. Alrighty. Now this here. Go here. Come on, hand. Listen to brain. Alright. No. No. Okay, there we go. Okay, so watch what I do here. Now, I want you to be close on the board. Like so. I grab you and make you stay close on the board, nice and tight. And now I'm going to solder you. This requires chafing away at the wire insulation without chafing away at other things. That resistor is fine taking the heat. It's a good sport. It's a nice shunt, big old shunt resistor. Okay, and now I have a nice secure connection in there. Do this. Beautiful. Isn't it beautiful? Absolutely beautiful. It's coming up to here. That could be insulated more of the way, but what are you gonna do? Not much. I could go back and redo that, but I would just be torturing myself over minutia. I really not going to torture myself over minutia. Yes, I am. I can't live with that. See how nice and secure this one is? You see how flimsy that bullshit is? Yeah, I can't live with that. I should learn to live with things. I can't leave well enough alone. Okay. I really should learn to leave well enough alone. Try again. Come on, left hand. Do what I say. Good left hand. All right. Bad. This can be so frustrating. I would totally take a certification course that taught your hand to listen to your brain. I don't think anybody offers the classes that I'm actually interested in. Okay, up and down. Hands up and down. Not left and right. Not left and right, you fucker. Up and down. Okay, we're going to scrape away that. I want to tin some of that. That's... Yes. Okay. This jumper wire used to take me, like, I'm not kidding, like, 40 seconds and they were all run. Okay. Whoever decided to put you here can suck my dick. Seriously. This thing here, whoever put in that little position, you can suck it. Okay. Okay, come on. Pay attention. Do as I say. Hey, look. My left hand's actually listening to me. Imagine that. It's not good. Okay. See, that's a joint. That's something that I wouldn't feel bad moving the board around with. Like, I have to feel like I can actually move the board around with the joint that I've made, or else I'm just not going to use it. Okay. A lot of time wasted for nothing. So... all that's left to do is reapply thermal paste and run ASD. Use my ESD safe paper towel provided by Amazon, Sparkle. Yep, that's an ESD safe paper towel. Got that as part of my IPC training certification course. Because if you clean the heatsink off with a non-IPC certified ESD safe paper towel, you could cause damage to the internals of the machine. So, you should always clean off the heatsink and all this stuff with alcohol. It's not nice to leave it all nasty. There are people that'll leave it all nasty, and they're not nice people. These products, Apple product, they have so many reasons to die. They die for virtually over nothing, all the time, constantly. And and very often it's because of heat, because they're not made to last more than a few years before they die. You know, as is evident with a 2006 MacBook Pro, 2007 MacBook Pro, 2008 MacBook Pro, not 2009 MacBook Pro, but then 2010 MacBook Pro with the tiny cap problem, then the 2011 MacBook Pro with the GPU problem, and the 2012 Retina with the GPU problem. It's just, and I'm confident. I'm confident it'll be 2013 and 14 very soon. It's coming. But yeah, so when you're working on a machine that's designed like such complete garbage like this one, you really you should be thinking about things like heat. You know, what thermal paste are you using? Are you actually applying new thermal paste using the old one? Because you can't use the old one again. When you're working on a machine that has the thermal properties of these piles of shit, you can cheap out on stuff like that. This is important. Making sure your fan is not chock full of dust is important. Because if it is chock full of dust, you'll be screwed. They will be back in a week or a month saying it doesn't work again. And it'll be your fault because it's your responsibility. It's your responsibility to know that you're working on a steaming pile of shit and to act and fix accordingly. You're not... Speaking of, that's their tester fan. That's my tester fan. This is their original fan. This is the original DCN board, which can GTFO because you fucking made me look like an idiot. I made myself look like an idiot, but this was the instrument that helped. And let's see. So I'd still like to ultrasonic all that flux off. That's the nice thing to do. There are times when I don't. Like there was one person who was arguing as to whether or not we actually performed a board repair, or we just told them it was one thing when it was another. So I've made sure to not ultrasonic the flux off of any of the boards that Repair Shop ever sends, so they can see every single last place, every single last thing that I did. And there's another person who would send stuff back every now and then saying like, we broke this thing while we were fixing something else. And it was like 1 or 2 resistors, so whatever. I'm not going to argue over 1 or 2 resistors, even though your machine would have never turned on for testing at all if they weren't there before you fucking rip them off. So if I'm going to fix it for free, then, when I really shouldn't be fixing shit for you at all, then I'll leave the flux on there. But for most people, I ultrasonic the flux off. It's just it's a nice thing to do. A surefire representation that I probably don't like you is if I don't ultrasonic the flux off of your boards before sending them back to you. Alrighty. So, what I want to do now is see if you pass all the sensor tests in the Apple hardware test. Apple Service Diagnostic, actually. Apple Service Diagnostic is much more useful than the Apple hardware test. It's just another one of those tools that you're not allowed to have that you have to like scour the internet for and find. The newer ASDs are even worse because they're much more difficult to get than any of the others. You actually have to find some Apple certified place that's willing to risk their business and livelihood to give you a fucking service disk and pray that you're not going to distribute it to the world. Because again, I'm a fucking terrorist because I want to fix products. Regular jihadi John right here. Trying to fix the VP0R issue on a 2013 MacBook Pro. Yep, that's me. Big fucking disruption to society. You have to understand that it just gets old after a while dealing with people who are just who like dedicate their professional lives to ensuring that you don't have one, and then kind of wonder why it is that you don't like them or their products. You wonder why I don't like them, and so. Alrighty, so we boot up into the Apple Service Diagnostic disk. Am I making too many assumptions in saying that you have a good keyboard? No, I'm not. Awesome. I have an Option key. And I have an Enter key, which is really all I asked for. Okay, let's see what I get. Let's see. I actually forgot what that sensor was for. SMC, Other High iSense. Current, IO0R. Other high side current sense, IO0R. let's see. So the fan is spinning really fast, which means there's a sensor issue. And the mouse is moving really slow, which means there's a sensor issue. So now the thing is, which one is it? Which one is it? Come on. Start up. So you can tell me which sensor you are, so we can go back and fix. Yawn. Ah, that scared the piss out of me. Freelancer.com. Sensor issues make things really slow. Okay, so I stopped recording for a second because that got really, really boring. So let's see which tests fail. So I'm going to set it to only run sensor tests because I'm not interested in the rest. I don't feel like waiting forever. So IO0R actually passes. That was the sensor that I ran those wires for. And VP0R passes, which is one of the other sensors that look kind of nasty. So now this really doesn't make much sense to me because every sensor test is passing. There's only a few left. Ahem, fail something for me. What the? You're broken. What the? What do you mean? Ah, this is bullshit. This is okay. This is something else. So I fixed the two sensor issues with a board that I thought had a bad SMC when the board actually only had a bad DCN board. And after all that, it still runs fucked up. The mouse moves really slow. It takes 10 minutes to boot because of clearly some type of sensor issue. And when I decide to run the sensor test in ASD, it fucking passes. It's time to play a video game and come back to this shit another day. I like Dota. I'm actually not that good at Dota anymore. But the reason is that I used to play it regularly, and now when I play it, it's usually after a day of work. So I work, I go out, I go to the gym, I do whatever I want to do, and then I get home at 11 or 12 or 1 in the morning. And at 1 in the morning, my head is just killed. So I'm not really that good at Dota compared to how I'd usually be at it when let's say it was like 2004 or 5 when 6.14b was out for the Warcraft 3 submap. Because back then it was like, I get home from school, I'm going to play a game, my mind is fresh because I decided, I had a choice between homework and playing Dota, and you bet your ass I'm not wasting my time on some fuck-ass high school homework. So that was pretty cool. But now it's like, you get home and it's just... So, but sometimes playing a game in the middle of the day is really helpful. I'm just curious if it fails anything else, so I'm just rerunning it. And I've set it to rerun the entire Apple hardware test. And again, I'm totally okay with the sensor being bad. I'm 100% okay with the sensor being bad. Which one? So this is one of those cases where it's just going to be something stupid. So let's see. Now, one of the things you can do here is you can run EFI version of ASD. And what you can do with EFI ASD, EFI ASD is going to allow you to check the temperature of each individual sensor. And then you can figure out which one is broken, because this one is bullshit. So this is pretty cool. I've shut down the entire computer from ASD. I've turned it off. And the fan is still spinning on high, and there's no light on the charger. So I've turned it off. I've fully powered it down. This is cool. Do you know why this is cool? Because my original fucking diagnosis of bad SMC was correct. I was right. I feel like that should be more rewarding. Now I kind of have to replace a chip that has 96 little balls on the bottom of it. Man, that's the rewarding feeling is really melting away right now inside of me. Yeah, it's 100% melted away. I don't care that I'm right anymore. I'm just mad. Okay, so. Oh yeah. Oh yeah, the light's not on. Oh, this is so fucked. Yeah, you are fucked hard. You are doing shit that you should not be doing. This shit is stuck. Look, I've never seen this before. The SMC fucking froze. I've seen a lot of SMC defects, but that little green light was stuck on for much longer than it should have been. Wow. Yeah, you're fucked. Let's see, if I do an SMC reset, what happens? That wasn't an SMC reset at all. The fan is spinning at a normal speed, and I haven't reset the SMC. Oh, I spoke too soon. This board is one for another day. Again, time for a video game. Okay, back to this piece of shit. So we're going to remove the SMC, which means misery and also hot air. So let's move over to the microscope camera over here. So the first thing that I need to do in order to remove it is turn on a really, really loud and obnoxious air filter. So let's take a look here. Let's take a look and just see what those corroded points are for anyway. So we have some nasty corroded points over here. And let's see what they actually do. So let's open up the Boardview software, zoom out, and go over here. And let's see, what does this stuff do? Okay. I can't find my board. I have no idea where it is. So I'm just going to open the file again. And let's see. So the corroded points that I have are... Let's see. So this stuff over here is for a system LED, like the light on the front of the hard drive cable. I don't give two shits about that at the moment. We have a corroded probe point over here for LPC plus GPIO. I don't care about that either. All right, so let's get to the work. So first thing I have to do is heat up the board a little bit so that I can remove that junk that sits around the SMC to hold it in place. I have to do this at a temperature that's not going to melt the solder. Because if I melt solder, then I'm going to rip off all those little components along with it. So I take the JBC and I put it to 175. You have to realize that if your hot air is set to 175, that the board is probably going to be like 155 to 160. So, and that's not going to melt lead-free solder. So I just lowered the hot air station a little bit. And we're just going to move around here like that. and this really annoying shit will start to come off. Of course, some of it will stick and stick to the chip, but that's life. So we take this. I don't really care if it sticks. I care about that stuff getting under a chip I'm reflowing, but this is a chip I'm removing, so I don't really care one way or the other. You know, I'm gonna be ripping all that shit off anyway. Hey, what do you know? A nasty looking resistor. What are you for, nasty looking resistor? Ah, you're a long PP3V. Oh, SMC TMS. Oh, this is for that shit for people who are actually allowed to program the SMC. See this? This thing over here is for the people who are actually allowed to program the SMC at Apple using this, some interface on the board. So I'm purposely leaving that out. I'm not. Fuck out of here if I'm fixing a feature that I'm not even allowed to use. Let them reprogram the SMC the same way I'm reprogramming it right now. Let them do this shit. Yeah, this is what they're gonna get to do. No nice little board interface for recoding for you. You get to suffer with the rest of us. That is what is fair. I find that to be quite fair and equitable. So now that part is just about done. So now I'm going to shove some flux under the SMC in the hopes that will make it easier to remove the SMC. I've left some of that shit, but again, I don't care about messing up the balls into the SMC because I'm not using them anyway. Okay, so we get some flux. Now I have to turn my hot air station to a temperature that will remove that SMC with no mercy. This JBC removes SMCs with no mercy. I mean, no, absolutely no mercy. You're going to see right now. So I just set it to heat up. So I'm going to heat it a little from far away first. Then I go in on the chip, and because the JBC is awesome, it just comes off like that. And of course I knock off a couple of components. But that is something I can fix. So I'm going to fix it. Okay, get my hot air station turned back on. Lower the temperature in the air. I do not need that much air to put two little resistors back on the board. This thing takes the SMC off like a champ. I feel bad because I did that video on the Weller where I was talking about how much I love the Weller and that it's not really much different than this, but it is. I mean, this is better than the Weller WHA 900. Like, it's not something that I noticed in a quick comparison, but it's something that really becomes obvious over long-term use. This kicks the shit out of the Weller. And the Weller kicks the shit out of the HAKKO. I mean, the Weller and the HAKKO are kind of on par, but the Weller can do things the HAKKO can't, like on a really... On a circuit board that is really, really densely populated with a lot of, just a lot of internal heat sinking and layers, it'll remove a connector heating it from the bottom, which is what I like to do to not destroy plastic connectors. It'll remove things that the HAKKO can't. So I don't want to shit on the WHA 900 too much because it's a good station. It's a really good station, but I don't know if it's just the fact that they don't sell curved nozzles. I don't know, because they should. They only sell curved nozzles for the thin one, not for the 4 to 6 millimeter. I don't know if it's that. I don't know if it's something else, but it just owns this thing. It owns the Weller so hard. The JBC owns the Weller. It's just the again, it's $1,800. I would never fucking buy this for myself. I would never in a million years spend $1,800 on a hot air station. I would have to be rich beyond my wildest dreams. I mean rich to the point where the idea of fixing consumer electronics for a living makes me physically sick because I'd rather spend the day swimming in my money. Like when I'm that rich, I'll spend $1,800 on a hot air station. But until then, I will use this. Oh, for fuck's sake. Enough with the beeping. Okay. Let's get rid of this old solder. I'm guessing some corrosion was probably over here originally because that's where you could see some junk on the board. So we're almost to the full temperature, but I'm going to get started a little sooner. So I have my nice big ball of leaded solder, and I'm just going around with it with the flux on there and making sure that I have every single pad tinned with leaded solder because that's going to make it easier to wick and make flat. The leaded solder gets picked up a lot easier than the lead-free, particularly since the lead-free solder probably saw corrosion and all sorts of other crap. Now the cool part about some of these SMCs that I got is that they actually came with the balls on them. I don't know if that was a mistake, if the person selling it actually realized they had done something convenient. Hopefully they never watched this video, but people would still buy that SMC at that price if it had no balls. But they have balls on them, so I mean that person has my. If you want to earn loyalty as a seller, you put balls on my SMC before you sell it to me. Like that person has my loyalty. So what I've done here is I've put the solder. I wicked all the old junk. Now I'm going to clean the area, and after I clean the area, so this is a clean room wipe. I buy these clean room wipes on eBay. They're useful for this stuff. See, it doesn't leave behind any little pieces of fabric or shit like that. I've gotten pretty good at dealing with Q-tips. As I said, if you keep turning it in the same direction instead of going back and forth, the fibers will get sucked up back on the Q-tip. But that's a really just way of doing things compared to the clean room wipe. So, yeah, so you could see that's pretty clean. One of the arguments that Jess and I used to argue about almost everything, and one of the things I used to say, because I would always wind up being right, I would say 99.9% of the time, if not 100%. I would say, sadly, I'm always right. Because very often we were arguing about things where I did not want to be correct. It was a downside for me to be correct because me being correct meant something bad. And I'm just thinking of that right now. Like, my original diagnosis was that this was the SMC. And sadly, I am right. I'm not saying that I like being always right. Always being right sucks. Because very often, I'm right about things that I don't, I really want to be wrong about. I want to be proven wrong. Show me how wrong I am. But such is life. So this SMC has balls on it. Do you see this? This is fucking beautiful. Look at this. I don't understand why somebody would be so nice as to sell me an SMC that has balls. But I am so spoiled away from that idea of buying the fucking boards for 15 or 20 bucks, ripping the SMCs off of them, reballing them. Because here's the thing. I can reball the SMC. I hate it, but I can do it. But when you do all that work and you realize that the board was liquid damaged, because I've been getting so many of those fucking boards lately where they're liquid damaged, and it's really bullshit. But when you did all that work to realize that if this doesn't work, whatever, I'll just grab another one, big fucking deal. But if I actually go through the work of removing an SMC without damaging it, then balling it, and it's not a good SMC, I'm gonna fucking scream. That's really. No ifs, ands, or buts about it. So let's see. So I'm going to put this to 300. I'm going to use a lot of air because it's hard to get over a big chip like this. I'm going to use like 79% air in the JBC. And we'll go at like 380 Celsius. And remember, I'm setting the temperature with my arm. So somebody actually asked me recently on the channel. They said, you know, are you right or left-handed? I notice you're always holding your tweezers with your left hand. To answer that question, I'm a right-handed person. But the tweezers are actually not as important to me as my air control and my temperature control. So I control the hot air. I usually have a hot air setting on my station that's far too high, but I control the hot air with distance. I control it with angle. Like I could approach something like this, I could approach it like this, I could approach it straight on, I could approach it really... Well, you can't see because you can't see what I'm doing outside the microscope. You can approach it like at an angle, you can approach it like this, you can go straight on the chip, you can do it from far away or close. You control your hot air temperature by how you hold the the hot air, the handpiece. So by how you hold the handpiece, you're controlling it. And I need that control to be very precise. The tweezers, I mean, I know that I'm not going to get the component straight on the pads with either fucking hand. You know, that's a given. Let's see, did I screw that up as well? I believe I did. One way to find out, though. I'm not sure if the balls were melted under it when I moved it. You're supposed to kind of wait for the flux to flow away. And once the flux is kind of flown away, you know that you're good to go in close on the chip. I didn't do that. That's bad. See, eventually you'll just see a really tiny, mild puddle of flux around the chip. And you'll know that you're good to go in inside of it. And we're getting very close to that point now. The chip's moving, which means I'm confident that my center balls have melted in addition to the other ones. Okay. Now those are really small balls on a relatively small chip compared to, let's say, a large BGA package, so it's going to dry faster than most. And just to assist it, some alcohol here. It'll dry up. It's still hot. Very hot. You can clean some of that excess flux off right now. Good opportunity since it's easier to clean flux while it's hot. That's my cooling method. I'm cooling down my SMC. With a little bit of alcohol on it. Let's get it to a temperature where I'm not going to feel bad if I turn it on. Yeah, we're just about there. That alcohol is evaporating more because of that wind stream from the air fume extractor than it is because the chip is actually hot. So first things first, is the soldering job good, and is the SMC that I bought from some random dude in a far-off land actually good? That's a question best answered by actually plugging this thing in. So let's take the machine. Alright. I like cleanness. I really like cleanness. Not reason why I fuss me anywhere. I like the mouse. Alright, so let's see. Now, I really shouldn't be going through the usual lines before I see the SMC, but it's kind of silly. Alright. Okay, first thing I should do is see if I even get a green light in the charger, because that, you know, that is first thing you need before you bother with anything else after an SMC. Green light and it turns on, so turn it off. I already have that test done. Now I know that it's worth my time to continue. So do you see what I did there? You know, of all the dumbass things I've done in this video, I think that was probably the first thing I did that was actually something that you should learn and emulate. You know, I don't want to wait. I'm not going to put this whole fucking thing back together only to figure out I have to take it back out. That's kind of, you know, that's silly for testing. So first thing I did in SMC, I want to see that the shit even turns on. So before I plug in anything into this machine, I'm just going to plug the charger in. If I see a green light in the fan spin, unplug, and now I know that I can plug the other things back in. Now I'm still not going to screw this thing into the damn machine, but we're just going to go one step further and see if when I boot up into ASD, if it runs slow and if my fan spins crazily all the time. So let's see what happens there. So I'm going to plug in my battery. I have all of my stuff plugged in. Now I'm going to boot into the Apple service test. Which I have here. Now again, remember, this actually passed the fucking test before, so, you know, I don't even know why I'm bothering. I should really just boot into a standard operating system and see how it works. Because again, this test that's supposed to tell me if there's anything wrong with the machine or the board didn't tell me that my SMC was dead. You know, again, it was not only was the machine running disturbingly slow, but in addition to running disturbingly slow and taking forever to boot and not doing anything right, the machine also was just, I turned it off and it went off. The light was no longer on up here. It was stopped and the fan was still spinning. And it was still, you know, fucked SMC. Thanks for nothing, ASD. So this is the noise from the fan. Standard. This is a USB 3 model, so with the SSD it should have booted pretty quickly. And one of the things you may notice if you look at the computer, I'm not sure how well that's going to deal with focusing with the light and the difference between the room and this. Let's probably lower the brightness on the screen so that you can tell. But when I move the mouse around, the mouse moves around at a standard pace. It doesn't lag or work like shit. And that's because the sensor issue is gone. And you can also see over here that the fan speed is spinning at a standard rate. So the fan is spinning at its standard speed. And again, I could run the test to show you that it passes. I don't really give two shits of a fuck about the Apple service test right now because it was totally fucking useless when it came to anything. This is probably one of the worst board repair videos I've ever done, from start to finish. I mean, usually, to be honest with you, the days that my hands don't work the way I want, I just don't bother doing videos or even board repair, just because it's a really annoying and frustrating thing to do. So, today I decided to film it either way, and there's also every single little step here diagnostically was completely wrong. I mean, just every single little thing went wrong. And a lot of the videos on the internet, again, what do we know? Well, you know what they do is they take like that 1 in 1,000 time that something was easy or simple, and they record that and may edit that, and they make it look like that's how it is every single time. And the problem with those videos is that you're going to watch them and you're going to say, I'm not as good as them. And that's really discouraging. And I don't want you to get discouraged. The whole point of this channel is to encourage you. And if you're encouraged by seeing people do stuff right, great. If you're encouraged even more by seeing people who are established professionally and successful in their field, failing and being complete idiots, then even better. Hopefully this helps you, and thank you for watching. And as always, I hope you learned something. All right, so I decided to come back to this on a later day. So funny thing is I decided to ultrasonic it so that it would look nice before showing it to you. As I said, I usually ultrasonic things if I actually do like the person that I'm doing work for and I have the time. And this is one of those instances where that was probably a bad idea because I actually managed to knock my wire off while I was toothbrushing it. I toothbrushed it a little hard that day, so I went into my regular toothbrush, and when I went in the ultrasonic to do that, I accidentally jabbed it. So let me just show you what it looks like after ultrasonic, and I'm also going to put my green conformal coating on it. So let's just get the microscope camera adjusted and show you what this looks like after that was done. So this is the first wire for the sensor issue. This is why I'm not a big fan of super zoom on the microscope. So see, the leg is not in focus, but the jumper is. Now the leg is in focus, but the jumper kind of isn't. So when you're zoomed out, you kind of get a greater overall area of focus. But when you're hyper zoomed in, you don't really get shit in terms of focus, which is why and especially if the microscope moves. So keep in mind that moving is actually with the regular stand. If you have the articulating arm, as Mark Schaefer can tell you from Practical Board Repair School, if you have that arm that moves, you are in for a nightmare if you actually zoom in all the way, because it just gets constant shaking. You're never in focus. And that's what it looks like on this side. So we're just going to green that a little bit. By a little bit, I mean a lot, because I love green. It's my favorite. So keep in mind, I'm not going to actually be touching the wire with the pen. I'm squeezing the pen, and I'm going on the side of it because I don't want to push it off the board. It's really easy to push too hard with this stuff and to wind up pushing the wire and just literally knocking it off of the board with pressure. So I have the green stuff going around it. And we're just going to get it on each side for strength. And when this stuff dries, what it does is, firstly, you're not going to, if you put a little piece of metal on top of that, it's not immediately going to show it off. So right now I'm trying my best to touch the chip and not the actual leg, not the actual jumper wire. I'm probably failing, but what are you going to do? And then, I failed a little right there. And then I'm going to do the same on the other side. So this stuff it's just good to finish off your work, make sure that it doesn't fall apart if somebody touches it, because sometimes people like to touch the wires and fuck with them. The main thing that green shit does for me, it's not really even so much about keeping the connection secure. It does keep the connection secure. You'll see when this stuff dries that even if you bump into it with something, that it's not going to fall off as easy. The main thing green stuff does to me is it tells the next person opening it, don't fucking touch this shit. It scares them. And that's exactly what I want. I want people to be scared of this. I want them to look at this and think that if they touch it, they're going to get terminal cancer or electrocuted or some terrible rare disease that's uncurable because it's this green goo. And if that happens, then it'll keep them from fucking with it and ruining whatever it is that I did. So that's the biggest effect that the green stuff has. Because people have asked, why don't you get the black one? Why don't you get the other colors? The other colors would blend in with the board. It wouldn't scare you. But again, you just see this big pile of green on your motherboard, and it's scary. It's intimidating, and that's exactly what it is I'm going for. I showed you this thing passing ASD, I believe, the other day, and passing my sensor test. Actually, I believe it. I'm pretty sure. I don't remember exactly, but it was passing the test. It just wasn't working because it was being a piece of shit because the SMC was bad. So it wasn't passing, even though it was passing, even though it was clearly fucked because the fans were spinning high and it was working really, really slow. But I showed you that it wasn't working really slow. So once this dries, so what I do is I don't put it in the oven at the really high temperature. I put it at maybe like 150 degrees, nothing crazy. It's going to cure quickly around this, and when you touch the wire, you're not going to be able to move it because it's going to be encased in this shit. And that's exactly what it is that I'm looking to accomplish here. So that's that. You can also see what the SMC area looks like. So you remember there was a lot of flux, a lot of rework that went on in that area. As I said, I have no plans on doing anything with this resistor. That resistor is used for people who want to reprogram the motherboard. So if people want to reprogram the SMC on the motherboard without taking it off, that's part of what that resistor is for. And again, if I don't get to reprogram the board, if I don't get to reprogram the SMC the easy way, then fuck you. Apple doesn't get to do it either. So I really had no interest in fixing that. That resistor can suck it for all I care. But the actual functionality of the SMC is intact. And yeah, just cleaned away all the flux and nasty shit under the chip. And that's that. As always, I hope that you learned something from the worst board repair video